I said is to get rid of fractions, because step one is to make this look pretty, right? You want this to look pretty. And I think fractions look ugly. There is a way of doing this without getting rid of fractions and where you keep the fractions and you solve for it. I'm not going to teach it that way. I'm teaching it where you get rid of the fractions, but you could do it the other way and still get the answer. But I want to teach you this way because as we get to harder questions, you'll need to know this method for harder questions. So this method here, get rid of fractions. So what you do is you look at the denominators of all the fractions. Negative 5x. What's the denominator of this? What's the invisible denominator? 1, right? If it's a whole number, there's always an invisible denominator of 1. So 1 is also the denominator here too. But in order to find the lowest common denominator, the 1 is just kind of like a moot point. So 2, 5, and 5, I asked myself, what is the lowest common multiple or lowest common denominator? What multiple do they have in common? What do you guys think it is? What does 2 and 5 have in common that's a multiple? 10. So if you think of the Venn diagram we did earlier in the beginning of class, the multiple they have in common is 10. So really important to be able to get that down. How do you find the lowest common multiple? So what you do with that, so how to get rid of fractions, you're going to, the key is you're going to multiply everything, and when I say everything, I mean everything, by the lowest common multiple. So I'm going to multiply this whole shebang by 10. So right here, I'm going to rewrite this so that you can see this. I'm going to have negative 5 over 1, just to have it there. The x, do you think the x goes in the numerator or the denominator? Numerator. So when you see an x on the side there, that's really in the numerator. So even though they write on the side, if it helps you, write it on top so you don't get confused. I'm going to multiply this fraction by 10. And then I'm going to have plus 3/2, and I'm going to multiply that fraction by 10. Equals to negative 1/5, the x goes on top, and I'm going to multiply that fraction by 10 minus 1/5, and I'm going to multiply that fraction by 10. So you multiply everything, the whole shebang by 10. And that's a-okay, because whatever you do one side, you're doing to the other side. You're still keeping the value or the integrity of the equation because you're multiplying everything by 10. So when you do that, let's go ahead and evaluate each fraction. So here, when you're multiplying by 10, is 10 in the numerator or the denominator? The numerator, right? So if you want, if it helps you to remind yourself that 10 is in the numerator, not the denominator, if you want, you can put 10 over 1, right? Same thing as saying 10. So you multiply the numerators together. What do you get when you multiply the numerators together? Negative 50x. This one here. When you're multiplying fractions, we just multiply fractions, right? We want to simplify first to make our life easier and then multiply it. So remember, the 10 is like a 10 over 1. If I have 3/2 times 10 over 1, what can I cancel out before I multiply things? The 2 and the 10. The 2 and the 10 here, what do they have in common?
5.
You can divide it out and it becomes a 5. They have a 2 in common. 2 divided by 2 becomes a 1, right? 2 divided by 2 is 1. What's 10 divided by 2? 5. Okay, so we just did multiplication of fractions. So now everything's simplified. Now I can multiply through. What do I get when I multiply these two together? 3 times 5 is 15. Over 1. Do I need to write over 1? No. Badam, no more fractions. It's just a 15. This 3/2 became just a 15. Okay? Equals, here, again, you could write this as 10 over 1 if it helps you. You don't have to, but just to remind yourself that the 10 is in the numerator. Does anything cancel out? What cancels out? the 5 and 10, right? So when you multiply fractions, before you multiply, you simplify first. The 10 and the 5, what do they have in common? The 5. So 5 divided by 5 is 1. 10 divided by 5 is 2. Now I can multiply. Negative 1x times 2 will give me negative 2. Negative 1 times 2 is just negative 2. And then don't forget the x sitting next to it. Over 1. Do I need to put over 1? No. Right? It's redundant to put over 1. And bam, no more fractions. It's gone. Last but not least, that was this. Negative 1/5 times 10. Again, you can write this as 10 over 1. Before you multiply through, what can you cancel out first? What can you reduce? The 5 and the 10 again. Right? So that's why we spent so much time on that worksheet on multiplying fractions, right? The 10 and the 5, what do they both divide by? 5. So 5 divided by 5 is? 10 divided by 5 is? 2. So therefore this becomes? Minus 1 times 2 is just 2. No more fractions. Still very pretty, right? So this ugly thing just became this. Yes, question?
Will we find situations where it's not going to end up with 1 and it's instead going to give us a mixed number?
Great question, and the answer is no. You will never, if you find the lowest common multiple, it will always cancel out with the bottom number. If you pick a wrong one, then you will end up getting a fraction. And then that's when you know, oh, it chose the wrong lowest common multiple. Okay. So whenever you multiply by a multiple of this, it'll always cancel out with the denominator. Great question. Any other questions? Yes?
Did you get the lowest common multiple?
Great. How did we get the number 10 as the lowest common multiple? So we saw that the denominator is 1, 2, 5, and 5, right? So unique numbers are 2 and 5. So remember when we did the Venn diagram? When we said, so now there's 2 numbers here, the numbers of 2 and 5. What are the multiples of 5? Can you help me out? What's the multiples of 5?
5, 10, 15, 20, 25.
Yada yada. What are the multiples of 2?
2, 4, 6, 8, 10, 4.
Yada yada. What's the number that they both have in common that's the lowest? 10. So 10 is the lowest common multiple. Thank you for asking. Another way you could have find the lowest common multiple is just multiply these two together and say, it might be 10. I don't know if it's the lowest common multiple, but it might be, right? And in this case it is.
So if it's 2, 5, and a 7, that's the...
So if it was it was 2, 5, and 7, what's the lowest common multiple? So I would start off with just multiplying all these numbers together. What's 2 times 5? 10 times 7? So I'm thinking maybe 70 is the lowest common multiple between all of them. But I'm like, that's a common multiple for sure, but is it the lowest? So I'm gonna be like, I wonder if it's something lower, so I'm gonna check something. I'm gonna take the multiples of 7. What are the multiples of 7? 7, 14, 21, 28, 35. Oh, hold up, 35. 35 is a multiple of 5, but is it a multiple of 2? No, because it's not even. So I'm going to keep going. What's after 35? 42, 49, 56, 63, and then, oh, hold up, 70. It's a multiple of 5, but is it a multiple of 2?
Yeah.
It sure is. So 70 is indeed the lowest common multiple. So this is how you could check it's the lowest, but if you end up picking like 140 or some other number, it still works, you just deal with big numbers. Great question. So the practice of having to find the lowest common multiple. All right, so this step was just step 1, which is to make it look pretty. Make it look pretty, to have it, more fractions. Now we go to step 2, which is what we did all of last week, which is to solve a linear equation with integers. Now we're dealing with integers. Okay? So we see the x's on the left and x's on the right. So review of last week. Where do you want your x? Let's make it decide. So I see you pointing to the left, to the left, to the left, right? So in my brain, I think I want it on the left. If I want my x's on the left, I want my, what does not belong in the left then? 15. Remember, to move things around, you add its opposite. What's the opposite of 15? 15, negative 15. And whatever you do one side, you must do to the other side. Okay? So on the left side here, 15 minus 15, poof, becomes 0. I get negative 50x is equal to negative 15. Which one can I add or subtract it to? Which animal? Negative 2. Why can't I add it to negative 2x? That's an x. Different animals. You can't add different animals. So therefore, the left becomes negative 2x. And then I can combine these two. Negative 2 minus 15 gives me negative 17. Are all my x's on the left-hand side? No, so I'm still not done with step 2. Step 2 is getting things all on one side. So what do I need to move around? Negative 2x. I want my negative 2x on the left, right? Because I wrote it down, I want it on the left. So when you move things around, you add and subtract its opposite. What's the opposite of negative 2x? Positive 2x. Whatever you do one side, you do to the other side. Great. And when we do that, can I combine these two animals? Yes, because they both have a x. So when you add or subtract, we get negative 48x equals to negative 17. These two become a 0, poof, negative 17. Are all my x's on one side? Am I done with step 2? Yes. Last but not least, step 3. Step 3 is to do what operation? Divide. Isolate the x. You isolate the x, you want x to be sitting by itself by dividing by the, starts with a C? Coefficient. The number that's attached to your x, the codependent number, right? The coefficient, the one's attached to you. So is it negative 17 or negative 48? Negative 48. That's one that's attached to the x, a codependent or coefficient. You divide by itself. So this is the step where you do division, right? I see students trying to do division up here. I'm like, hold up. Or they're trying to add 48x to both sides. And I say, nope, the last step is to divide, right? Negative 48 divided by negative 48 gives you? Gives you what? Not 0? 1. Negative 48 divided by negative 48 is just 1. So you end up just getting 1x, which is the same thing as just x. Equals this divided by this. What does that give you? 17 over, just a positive version, right? 17 over 48. Can I simplify 17 over 48? No. So 1x, or I could just say x is equal to 17 over 48 is your final answer. And if you want, you can always plug it in to check your work. But I'm looking at this, I'm like, oh, there's a lot of fractions. I think I'm going to trust my work. Okay. Any questions? No questions? All right. Peace.